In this video, we'll learn about double integration over general region. There are two different cases involving double integration over general region. Let's start off by considering the first case. With case 1, we have our region D defined to be xy such that x lies in between A and B and y lies in between h of x1 and h of x2. So here y is defined to be the general region. So to compute this iterated integral, we first compute with respect to the variable that has the general region. So here we compute with respect to y first because y has the general region h of x1 and h2 of x1. Then we now compute with respect to the variable that has the finite region. So that's we are going to compute with respect to x. With case 2, we have the region D defined to be xy such that x lies in between g1 of y and g2 of y and y lies in between C and D. So here x is defined to be the general region. So we should first compute with respect to x firstly, then we compute with respect to y. So that's the iterated integral will be given below. We now start solving some examples associated with double integral over general region. With example 1, we have to compute the integral of x on y over the region D such that D is defined to be x lying in between y and y cube and y lying in between 1 and 2. So here x is defined to be the general region. Here, since x is defined to be the general region, we first have to integrate with respect to x. Then we can now integrate our results with respect to y. So we take the inner integral, then we integrate with respect to x. To integrate an exponential function, we first have to differentiate the exponents and divide. So now let's differentiate the exponents. So you're going to have d dx of xy. So that's going to give us 1 over y. So we are going to divide our original function, which is giving us this guy ex divided by y. So that's going to give us exy divided by 1 over y, then the range of integration y cube. This can be rewritten as exy, then from y to y cube. So now we integrated with respect to x, so we now substitute in the range of integration. For the upper integration, we are going to have x is now y cube, so here is going to be y cube on y, then minus that of the lower range of integration, so that's going to be y on y. Now let's simplify this further. So simplifying this gives y squared minus y exponent 1. Here, our main goal is to integrate this guy given below, but the integral of the inner integral is given as what we have in here. So we now substitute this guy back into the original question. So we are going to have integral from 1 to 2 y squared minus y exponent 1 dy. To integrate the first term, we use u substitution by letting u be equal to y squared. So that's going to give us 1/2 y squared, then minus. So here also we should note that exponent 1 is a constant, so we just have to integrate y. So which is going to give us y squared on 2 exponent 1. Then the range of integration 1, 2. Substituting the range of integration gives 1/2 so here y is now 2 So that's going to be 4 minus, here also y is now 2, so that's going to be 4 on 2 e exponent 1. Then minus that of the lower range, so that's going to be 1/2 e exponent 1 minus 1/2 e exponent 1. So now this guy will go to 0. Now let's simplify this guy. So that's going to give us 1/2 e exponent 4 minus 2 e exponent 1. Hence, our answer to the double integral question is given below. With our second and last example, we are to integrate the function 2xy minus y cube over the region D, defined to be x lying in between 0 and 1, and y lying between x cubed and square root of x. So here, y is defined to be the general region. So we should first have to integrate with respect to y before we integrate with respect to x. So let's set up our double integral. Setting up the double integral gives the expression below. So now we have to integrate the inner integral first. So we take this guy out and then we integrate. Now let's integrate the inner integral with respect to y. So that's going to give us 2xy squared divided by 2 minus y4 on 4. Then the range of integration, x cubed square root of x. So this will be simplified to xy squared minus y4 on 4, then from x cubed to square root of x. Now we're now substituting the range of integration. So for the upper integral, we are going to have x, so y is now square root of x. So here will be square root of x all squared minus square root of x exponent 4 divided by 4. Then minus that of the lower range of integration. So now y is now x cubed. So we are going to have x cubed. Then y is being squared. So here is going to be squared minus y is now x exponent 3. So that will be x exponent 3 all exponent 4 divided by 4. Now let's simplify this guy. So you have x, the square root of x all squared will give us x minus square root of x exponent 4 will give us x squared divided by 4, then minus, so here will give us x multiplying x exponent 6, then minus x exponent 12 divided by 4. Simplifying this guy gives x squared minus x squared on 4, then minus x exponent 7. So minus will give us plus. So that will be plus x exponent 12 on 4. Let's simplify by adding like terms. So here we are going to have 3 exponent 4 x squared minus x exponent 7 plus x12 on 4. Our next step is to substitute this guy in place of the inner integral. Then we now integrate with respect to x. So we now integrate with respect to x. So this is going to give us 3x cubed on 4 times 3 minus x7 on 7 plus x exponent 13 on 4 times 13. Then from 0 to 1. Simplifying this gives x cubed on 4 minus x7 on 7 plus x13 on 52 from 0 to 1. Now let's substitute in the range of integration. So that's going to give us 1 on 4 minus 1 over 7 plus 1 over 52. That's for the upper integral minus that of the lower range of integration. So that's going to give us 0. And this is going to give us 23 on 182. Hence, our answer to the iterated integral is given below. See you in the next video. Thank you for watching.